Okay, so as a design engineer, we should know the engineering design process, or how to read any tender, any project, and how to start designing work and any tender or any project. So when we start designing, this step number one, we need to take the project, and first of all we need to check that what is scope of work, or in short we call as the SOW, given in that project, and that to be executed for the project by your EPC company or by your company in which you are working as a design engineer. The correct understanding of scope of work is important. About the scope of work is very important for the accurate detailed designing. So that is the first step. We take the project and read out what is the scope of work given in that project. I hope this point is clear to everyone. And if it is fine, please active on the chat box. At least you can type CL or anything, so that it will be okay and we can proceed to the next point like that. Okay, so uh, now let us take overall that what kind of the project come into market, or what kind of the project comes for the designing. So I have made the list for all kind of the project when we talk about the service stations. So there are many kind of the service station project work. Project by government electricity board, that may be the state electricity board, that maybe by the central electricity, that is called the power grid PGCIL. So the first project, or most of the project that come by the government electricity boards. Every state have their own electricity boards, and we have the power grid, that is the central grid, that is the national grid, and each country have their own grid. Like in India we have the power grid, in Bangladesh we have the PGCB power grid company of Bangladesh, in Nepal we have NEA, national the Nepal electricity authority, in Saudi we have SEC, Saudi electricity company. Every country have their own grid company. In India we have the power grid. So the project come from this electricity board, or the project come from the power grid. Second project of the service system come from the government power producers. In India, if we talk, so it may come from the NTPC, it may come from NHPC, it may come from the nuclear power corporation. So from these company also, uh, like open the bid, or they have the substation project. The third kind of the project, and that is very much popular nowadays, that is by the independent power producer, that in short form we call as the IPP. And independent power producers are non-utility generator, or non-government generator of the power, is an entity that is a public utility but owns facility to generate electric power for sell to utilities or for sell to government and end users. For example, the company who working in the solar, the company who working in the wind, hydro, small hydro, and the private company that install the power plant for their own purpose, and the surplus power they send to the utilities. They sell to the utilities, and against that they do the power trading, that is called the power purchase agreement or power trading. So these kind of the independent power producers company, for the power evacuations they need to install the substations. So they also open the bid, they also invite the bid, they also have the bid, they also have the tender to execute the substations based on the capacity of the power what they are going to purchase, what they are going to produce. Right, suppose if they are producing around 300 MVA power, so they will go to the 220 kV substations. If they are producing around 50 MVA power, so they may go to 132 kilovolt substations. If they are producing 1000 megawatt power, so they are 600 megawatt power, so they will use the 400 kilovolt substations. Like that, the voltage depend on the what amount of the power they are producing. And the fourth uh, type of the project that come into market, that is the large scale industries having load in MVA. they need to install the substations to take power at their own industry, to take power on higher voltage, then step down with help of the substations and for their self use. The company who that for we talking, that is any oil and gas industry, they have a lot of big motors, so their load is an MVA or load is megawatt, so they need to install the power plant, the substations at their own end. The steel plant, because again the any big plant who have the MVA load or who have the few several megawatt load, they need to have the substation at their own entity, at their own site. So these company also open the project for the substations. The company also invite bid for the substations. And then when we go to the transportations, then railways that having the TSS to get the 25 kilovolt services. So this railway also open the tender, open the project to execute the substations. So we need to take the project. These are the sources of the project, and we need to check out the scope of the work what given in that project. Right? I'm just telling you, if we take any solar power plant, so this is a site picture where we have the solar PV cell, as you can see in the site picture here. And thereafter to evacuate the power to the grid, as you can see here, this is the grid transmission line, this is the grid transmission tower. Here we have this step up transformer, power transformer, and then what power we are producing with help of the solar PV cells, we step up with help of the transformer and we feed to the grid. So this ground mounted solar also required a substation here, right? So this is called the two trafo. Here two trafos, this is called a trafo bay, then this is called as the line bay. The bay that going towards the line, this is called the line bay. And this bay is, like we can see their top view, this is the top view. So from the trafo till this bus bar, this circuit we call as the trafo bay. So here we have two trafo bay. From the transformer to this R phase, Y phase and B phase conductor, and this is called as the bus bar, the bus bar that we use in college time, the bus bar. So this is the bus bar side picture. As we can see, this we have taken the conductor, ACSR conductor, to make the bus bar, and that we have a string with help of the tower and the gantry. This is tower and this is called as the gantry or beam. So this bay we call as the trafo bay. Trafo, and here we have two transformer bay, and the circuit that start from the bus bar and going towards the line bay are feeding to the line bay called are feeding to the transmission circuit we called as the line bay. As we can see here, this is feeding to the transmission circuit. So this bay we will call as the line bay, transmission line bay. I hope the transformer bay and the line bay is clear to everyone. This how to read any tender, how to start any tender. So first of all, we have to take that project. These are the sources that company open the tender, open the project for the substations. So we need to take the project, we need to go through scope of the work, and then in the scope of the work we need to check that how many, what is the quantity of trafo that we need to install here, the transformer quantity 1 2 or 3, what is we need to install, the voltage rating of the transformer that is given in the tender, and then how many trafo bay, how many transformer bay, 1 bay, 2 bay, 3 bay, or how many bay, and then how many transmission line bay. So these informations given in the tender scope of the work. I hope this is clear to, yeah, Sardas, thank you. So please be active on the chat box so that it is, if anyone have any difficulty, any doubt, please post their query in the chat box, and in the last of the session we will take all the queries, and in the last we will also have the Q&A session so that we can discuss their query. Even though I am going with the very basics, so covering all the aspect from the starting from the basics. Okay, so this is one, like here they have their own industry, anything, and they have the big power, so they need to install the substations at their own factory, at their own plant, right? So I hope this what is the big. So we have taken this project in the like last session we have taken this project, that have the 400 by 220 kV substations, 400 by 220 kilo voltage, 2 into 500 MVA transformer that we are using, 5 and the place is Dumka. So this is 400 kilovoltage side scope of the work here that is given, and 220 kilovoltage side scope of the work that is given here. So ICT means, already we have discussed, ICT stands for the interconnecting transformer, right? So ICT by two numbers, ICT by two numbers, it means the transformer by two numbers, right? Now transformer by two numbers, line by two numbers. So what is the bay? Bay means, it is clear, bay representing a power line circuit in substation which connect a circuit such as transmission line circuit or transformer circuit to a common electrical bus bar, that is called as the bay. I again repeat, what is the meaning of bay? Bay representing a power line circuit, and this circuit will have 3 RYB phase in substation which connects a circuit such as circuit transmission line circuit to the bus bar, or the transformer circuit to the bus bar, we call as the bay. So if this connecting transmission line circuit to the bus bar, then we will call as the line bay, and if they connecting the transformer circuit to the bus bar, then we call as the transformer bay. So the bay means clear, two line bay means two transmission line circuit, ICT bay 2 means there is two transformer circuit that we have, and bus reactor that also we are using. So why we use the bus reactor? In the last session we have discussed why required the bus reactor. Okay, again I will simulate the requirement of bus reactor today also with help of the ETAP software. Okay, so step 1 is clear to everyone. We need to, so let me note down all the major key points which we are discussing. So we are discussing how to read any tender, or we are discussing the design process, the design process design process for any project, that is we are discussing now for any project. And this step number 1 that we discuss now, that we need to take the project and we need to check that what is the SOW, scope of the work given in that project. The step number, then we are moving to step number 2. Step number 2, step 1 is scope of the work. Step 2 is, yeah, okay, thank you. So step number 2, read and clearly understand the technical requirement of the project. Make a note that what is requirement of that project. For designing of any project, we must follow following documents or reference. So step number 2 is that read out the technical specifications, read out the project requirement. Read the technical specifications, or we can say read the technical requirement. And when we take the project between, then we do the we sign a contract between the client and the EPC contractor, then we call as this read the contract agreement, read the contract requirement. We can call as the read the contract requirement, contract technical requirement, because the commercial and the requirement will be taken care by the another team. You need to take care of the technical requirement, contract technical requirement, read out. So what document we have to go through, or what kind of the document we should have, or what kind of the document knowledge we should have. So coming back to this, so first of all we need to go through, or we need to check the technical specifications or the requirement of the requirement, contract agreement, we can see in a correct way. Second, sometimes what happens during the bidding stage, there is several company who is bidding for that project, and these company ask some clarifications, some questions that is not for the specifications that is not given clearly in that project. So for that query, the EPC company issue the bid clarification document. So we have to go to technical specifications, plus we have to ask to our tendering team, the project team, that is there any bid clarifications at the bidding stage happened or given by the client. So we need to go through that bid clarification document also. Bidding stage clarifications asked by EPC or any specific requirement provided by client at later stage bid. So technical specifications, technical requirement, bid clarification requirement. These two document we should have. Third document that we should know or we should have, what is the local country electrical grid requirement, in which country that project, that country local grid requirement we have to follow. Suppose I am working in Nepal, so we have to take that what is the Nepal electricity authority requirement. If I am working for Saudi, so I will take that what is the SEC requirement. So they have some additional requirement that is not given in the tender, that is not given in the IEEE standard. They may have some local regulations, local requirement also. So we have to go through that what is the local country electrical grid requirement or electricity authority requirement. If we talk in India, so we in India we have the CEA, that is called Central Electricity Authority. So they have some regulations to execute any project. So we should aware that what is the CEA regulations for the substations. This we should aware. And we can take CBIP also. This is some technical manuals. So if anything, any data is not given in the technical specifications, so that data we can take from the CEA or we can take from the CBIP. Right? Third, fourth document that we will follow to execute the project, to design the project, that is the IC and IEEE standards. This also. Now, one important point here, suppose any parameters you have taken that is given in the tender some different value, in local grid some different value, in IC and IEEE some different value. So what you will follow, which requirement will supersede? Suppose any common parameters, but every document has the different values. There might be that case that IEC telling something different, CA telling something different, and then technical specification telling something different, bit clarification telling something different. Fourth, not matching. Then what you will follow? I'm just asking, in your suppose designing career, if these conditions came, then how you will tackle that case? Yeah.
Sir, the particular standard we follow, because
So in that case, we will not go with the CEA to it. First of all, for my project, we need to fill out, we need to take care that what is my project requirement, not the CEA, the project requirement. So we can go with the technical specifications or we can go with the bid clarifications. But during the bid clarifications or during the considerations, we may reconfirm by the client that as per the bid clarifications, this is this value given as the X, but as per the CEA, this value is given as the Y, but as per the IC, this value is given as the Z. So please suggest that which parameter we should follow. And client is not telling something, they are not reachable, they are not reply to your query, or you do not have any communications established between the client and you. In that case, we can go with the bid clarification document. This. Okay. I hope this is fine. Bid because first of all, we need to go as per the project requirement. If it is given, if it is not given, then CEA, IC, these all is the reference document. From that, we will select the values. The better things that we discuss with the client, and we put all the values given by the different documents, and let the client take the decision that what they wanted to take. And if they could not take, then we will go with the bit clarification document. I hope that is fine. That is making some sense. And in case of conflict, that uh, this value is CA telling something different. Suppose case number 2, we do not have requirement in the bid, but we have the value in the CEA, we have the value in the IC, we have some value in the grid requirement. In that case, what I can do in case of conflict between the standards and the technical specifications, the second approach, the more stringent value of two cell may govern with consent of the client. I will take the value which is the higher value that I can take with consent of the client. Which one is the more stringent, or which one is the more higher value, that also we can take. Okay, so now, okay, case is that this case when we work this case, this kind of this step number 2, this kind of the method we follow when we work for any utility kind of service business, when we work for any government electricity board, state electricity board, or power grid kind of service station, or NTPC kind of service station, or LHPC kind of service. It means for any government project, since government have established, they have their own technical teams, they have technical specifications, they have the fixed requirement, so that we need to follow. But when we work for any independent power producers, when we work for any solar, wind, hydro, any yeah, TSS also have their own specifications, but when we work for any independent power producers, IPP, solar, wind and hydro, private company, in that case, we do not have any technical specifications in the detail. We do not have any technical specifications in the detail. Only we have a brief document, brief requirement of the project. But on basis of that brief document, we have to design the complete service stations. But that document is not enough, more enough. Let me show you some example what I'm trying to say. So if I am going to this any government service station tender project, and if I open the tender, suppose this is one tender that we are taking, the 142 page document. So they have 142 page, and that they have given the requirement. This is again the government kind of the tender, as you can see here, government kind of the tender. This is let me take the ownership, who's the owner, the energy department, government of Jharkhand. So that is the government project. Now if we come any independent power producers tender, let me open that if I have in my system now. Let me take, yeah, so that is, yeah, that is called the DBR, design basis report. That is called the DBR, design basis report. And as you can see here, this is total 13 page document. So to execute a 220 by 33 kilovoltage wind farm pooling service station that have the 300 MVA power capacity, 220 by 33 kilovoltage. But what the client, that is the Alphanor is the client, but client given us only 13 page document. In that they mention about the project introduction, the site data, the codes and standard, and then scope of the work they mention here, number of 220 kV site bay, 33 kV site bay, and then control room building, how many room required in the building, technical data for the switch yard, the voltage rating, and then some design criteria, but that is also not correct. But that was also not correct. We commented on that, this is not the correct. Okay, so, and suppose this is correct, but total 13 page document we have, but for others we do not have any reference. So how we will design this kind of the project? Any idea? Total 13 page. So in that we have this design clearances, what the clearances required they have given, the earthing system they have given the requirement. Earthing conductor is sized for 40 kilometer per second. If you can see here, earthing conductor is sized But when we go here, then earthing data is given, that what should be the earthing, that is given. Okay, so in this kind of the project only we have the brief requirement, but other requirement we have to calculate. We have to go as per the calculations. So what is the approach for that kind of the surface stations, for that kind of substations? So this is for the government, this approach we follow for the government. But when we come for any independent power producers, so when we work on project by government, electricity board, grid project, electricity board or grid, the project requirement and the equipment rating is given in tender. Why it is given the tender? Because the government making that project for considering the next 30-year requirement. So suppose if you go to refer to this tender which I have given to all of you, you go and you see that the scope of the work given here, and along with that every equipment rating is also given. You can see here equipment and facilities, they have given the equipment current rating. And if you go power trafo, their rating, their each and every detail is given in here, because they are considering that what may be the load growth for the next 30 years. So considering that requirement, they provide all the equipment current rating, all the equipment rating. So current rating, fault current rating, voltage rating, each and everything is given the tender. But when we were this kind of the wind or this kind of the solar services, so we do not have any equipment rating. As you can see, there is no any equipment rating given in that. Here this is the only clearances, but there is no any equipment rating. That equipment rating this level, but equipment rate current rating is not available here. Okay, so what I mean to say, I hope this statement is clear to everyone. When we work for government substations, the equipment rating is given in tender. So when we will go to the equipment selection and sizing, for the equipment selection and for the equipment sizing, we will go to the tender specifications. We will see that what is required in the tender, what kind of the equipment they have asked. Like if we go any breaker, any equipment, circuit breaker, so this is they have already given the type, SF6 type. So equipment type is given, equipment rating is also given, 420 kilo voltage and 2500 ampere or 1600 ampere, 3150 and 4000 ampere rated continuous current rating. So for this kind of project, I will take the equipment type directly from this tender and equipment rating directly from this tender. But when it comes to the renewables, when it comes to the independent power producers, then we don't have such kind of detailed specifications. In that case, how we will proceed? And why they give this rating, why they provide this rating? Because if the client do not provide this rating, so every company will calculate the equipment rating based on their own assumption, based on their own considerations, right? Because if you see here, they are taking 500 MVA trafo, they are taking 500 MVA trafo. Let us see, let us go to the and perform on calculations. Let us go to the this scope of the work, and let us find out what should be the equipment rating. So rating is 500 MVA, voltage 400 by 220 kilovolt. So what should be the equipment rating as per the calculations? If we go, if do not as per the tender, so 500 MVA, right, multiplied by 1000, convert into the kVA, divide by 1.732 and divide by 400 or 220, any voltage we can take. Let us do 400 kilovolts. So how much it is coming? 721 ampere, right? Requirement is 721 ampere. Just take 10% margin, it will 1000 ampere is the requirement. But what they are asking, so if I need to calculate, I will take 1000 ampere rating, but are as per the rating, are as per the rating that available in the market. Suppose 1000 is not available for the 400 kilovoltage, but whatever the lowest rating available, that I will take in order to save the cost. But they, what they are asking, they are asking to provide the 3000 ampere equipment, as you can see in the tender. It means they are freezing this tender, this government, this project freeze the equipment rating. Why they freeze? Because they are not taking the current loading, they are taking the future loading also, that may come in the future, right? They, that may come in the future. It means If you see in the scope of the work, they have some future base ICT bay future ICT bay one numbers. It means one ICTP will come in the future. So total 2. So 721 multiplied by 2 right now. So it will 1443 is a requirement, but one is the future. That also we have to calculate. We have to add. So plus I will go to 741 one more. Right. So 2184 is the requirement, but they're asking 3000 because they are taking some additional margin. They are taking some additional uh, margin for the next 30 years, that the age, that is the service life of that substations. So that is why we have to follow as per the tender specifications, as per the tender rating. But the point is that when we work for any independent power producers, then in that case we do not follow this method. In that case we have to calculate all equipment current rating as per my plant capacity. It means how much solar I'm going to produce, how much solar I'm going to produce. Suppose I'm taking any solar site, so this my solar site, my PV cell rating is decided, is confirmed, that how much power I'm going to produce. So I will select my equipment rating not by as per the grid. I will take this equipment rating based on my PV cell capacity, that how much power I'm going to produce. So based on that power, based the voltage, I will calculate my equipment current rating and short circuit rating and so on, and based on that we will select the equipment here. So the difference is that the major difference is that when we work for government, we'll go with the tender. When we work for any IPP kind of the project in private company, then we don't have any detailed project technical specifications. Only we have a brief requirement of project, not in the detail. So we need to perform calculations for all the equipment rating. So in this session, in this program, we will take this kind of the project, IPP kind of the project, and we will calculate all the equipment rating. And that, if you see in the syllabus also, we have keep module to how to calculate the equipment selection, sizing, calculation, the case study. Right. So we are going that there is no equipment rating, then how to calculate the equipment rating for that project. So we are taking this case also, because this case is clear to everyone. This case is already clear. This case that we need to learn. I hope that is making some sense. So calculations we will perform, and for other parameters, in this case we need to aware. For other parameters means type of the equipment and some specifications of the equipment. In that this case we need to aware the electricity board requirement, the local country electrical grid requirement, or electricity authority requirement. So based on these requirement, we will refer this requirement and we will select the equipment specifications. And if any value not given in the board requirement in the CA, then we can go to the IEC and IEEE standards for the parameter selections. So we should know the IEC and IEEE standards also. Like if that is reason, if you see any job openings, in the job openings comes, like let me see if I have any job descriptions. Any job descriptions? Yeah, SoftBank is the renewable based company. Now I think Adani have taken over this company. So if you see this system manager, their skills, uh, the subject matter expert, and then you can see uh, sound knowledge of relevant engineering codes and standards. This is one skill that required to this manager, to the design manager, that they have sound knowledge relevant engineering code. So we will take this relevant engineering codes and standard to refer uh, for the parameter selections. Parameter selection, I mean to say that any value, that any, suppose the breaking time of the breaker or making time of the breaker. So the making time not calculated, it is taken as per the IC IEEE standards guideline. So this is what I mean to say. I hope this is making some sense and I'm clear what I'm how we need to proceed with this kind of the service business, right? Please let me know if anyone have any query in step number 1 that we discuss scope of work, step number 2 that we discuss step number 1 when we take the project we have to go to scope of work, that is clear. Step number two, we need to read out the technical specifications, contract requirement plus the bit clarifications that we discuss. Plus we should have the knowledge of CEA, Electricity Authority. Plus we should have the IC and IEEE standards, IC and IEEE standards, so that we can refer all these standards. And we discussed that when we work for any renewables power plant, any IPP, in independent power producers, in that case we have to take this CEA, this IC. There is no any bid clarifications or these kind of documents. So we have only the design basis report, or we have the brief requirement. So for that we need to calculate all the requirements, and we can follow the CE and IC as the reference standard. Please let me know if so far it is clear to everyone.
Sir, I have one query, sir.
Yeah.
Hello.
Yes.
Sir, in our steel plant substation, the equipment approval come from MSCBA,
Correct.
MSCTCL.
Yes, correct, correct. Because they are the local electricity authority. Okay.
Okay, sir.
So that is why whatever you are doing, you have to electricity board requirement right now, and your electricity board is the MSTCL, so you have to take approval from the electricity board, that is
Yes,
MSTCL.
sir. So the, all GIS requirement rating, they are coming from approval from there. Then we will installation or commission. That's
Correct,
why.
correct. Because we are taking the power from that board, so we need to consult their engineers also. We need to keep in the loop that we are making this kind of stuff, because we will take the power from the MSETCL right now, from the electricity board.
Yes.
That is why we need to also include that they need to improve approve the equipment ratings. Yeah. Okay. Okay,
Okay.
Alkis.
Okay, sir.
So two stuff we discussed so far. So let us discuss what is the list of IC and IEEE standards that we need to follow. So this is the name of the IC standard that we will follow. For the lightning or surge arrestor, we will follow the IC 60099 part number 4. The CVT for the CVT capacity voltage transformer, we will follow the IC 61869 part number 5. For the wave trap or line trap, we will follow the IC 60353. For the isolator or disconnect, we will follow the IC 62271-102. For the CT, or I mean to say current transformer, we will follow the IC 61869 part number 1 and part number 2. For the circuit breaker, we will follow the IEC 62271-100. For the power transformer, IEC 60076. For the reactor, IEC 60076, same as the power transformer, but part number 6 is specifically for the reactors. Then for the cable, IEC 60502. For the string insulators, IEC 60305, IEC 60383, not the double three, 60383. For the electrical complete installations, we will follow the IEC 61936 standards. So please make sure that everyone have these all standards in their own computer, so that they can refer these standards when required. Right? So this is one kind of the job profiles also, as we can see here. The sound and knowledge of relevant engineering codes, the IEC codes, and the standards that we are following. The CA and the IEC, that is okay. So this is the list of the IC standards that we follow. Let me explain why this standard knowledge is important. What is the relevant of this standards? So I have taken some snapshot of the project to explain why this standards is important. Yeah, suppose, as I said in session number 2, that every line sent reactor will have the NGR, right? That was my statement, if you all remember. I have taken one snapshot of the line transmission line B. Just line portion we have taken. The LA CVT wave trap. This drawing is not very much clear because also I have taken the snapshot from uh, a printed drawing. And then it is taken, a branch taken here, and that is connected with the line reactor. This portion please consider as the line reactor. Again, I'm telling this drawing is not clear, but I just wanted to keep this in the discuss. That is why I've taken the snapshot, this line reactor. But if you see, this reactor is going to the ground, but between the ground symbol, as you can see here, and the reactor, there is a equipment called NGR. This yellow portion, I hope this is clear, visible. This is written as the NGR. This NGR stands for the neutral grounding. What is the meaning of NGR?
Neutral grounding reactor.
Yeah, neutral grounding reactor. It is not the neutral grounding resistance, as everyone understood the neutral grounding resistance, but it is not like that. Okay, so I have put this NGR between the ground and this reactor. So what is the reference of this NGR? Why it, as a design engineer, you need to select the NGR here. So for this selection, this IC is the this IC snapshot is the reference. So when we know the IC, when we read out this IC, then we will have the idea that how to proceed with the designing. So as you can see here, by help of IC, we came to know that line sent reactor needed the NGR between the neutral terminal and the ground. So refer to the IC 60076, as I said, that for the reactor 60076 part number 6. So I have taken the snapshot from the IC 60076 part number 6, page number 97, right? Clause number A4, this is the annexure A. In the annexure A, point number 4, send reactor for lines with the single pole auto reclosing. This is the feature that we required inside the circuit breaker. So send reactor connected to a line or grid with an effective earth neutral, or normally earth at reactor neutral in some cases of transmission system, where the line has single pole auto reclosing, and every line have the single pole auto reclosing when the voltage rating is beyond 220 beyond 132 kilovoltage. In that case, every breaker have the auto reclosing facility. What I mean to auto reclosing, I will explain this statement, this word, when I will come on the circuit breaker session. I have the beautiful explanation for the auto reclosing. But for now, we just need to know the importance of this standard knowing. So as per this standard, uh, this line has single pole auto reclosing. It may be,
Hello, sir.
it may be,
Hello.
please one second.
Okay.
Indrajit, please mute yourself, and we have one session in the last that is called Q&A session. So whatever your doubt you have, we will discuss in that session. Okay, Indrajit?
Okay, sir. Okay.
So let me complete my first agenda. Thereafter, we'll keep one session in the last 10 minutes only for the discussion. In that, I will not tell anything from my side. I will only listen your queries and I will reply. So uh, this install, it may be preferably to control the, and why this is required, it is to control the secondary arc current. I hope when you study the power system, you know about the arc current and secondary arc current also, secondary arc current, and transient recovery voltage. Why this, what is the meaning of transient recovery voltage? Secondary arc current means what happens, that we have the LNC circuit right now, the LNC circuit. So due to the LNC circuit, due to the inductance in the capacitance circuit, this secondary arc and the transient recovery voltage comes into the circuit breaker for single line to earth fault. So before closing of the circuit breaker, we need to quench the arc current. We need to quench the recovery. We need to quench the arc current. So this NGR helping to quench the arc current, and to support this statement, to support this IC statement, even though IC is not required any support, but even though I have also forwarded some research paper on this statement also, right? So hope you have gone through that research paper. So this is so when I mean to say, when we know the IC, that when we know the IC requirement, when we know the IC, then only during the designing we can use this kind of the equipment in the drawings. Otherwise, we cannot use. So that is the important, that we should know. At least we should read one times this IC standard, not theoretically, but once times we should go through. Let me tell second example. of the IC standards. This is the disk insulator. I think everyone see in their life disk insulator, transmission tower having this kind of the disk insulators, right? Disk insulator. Have you ever think what should be the diameter of this disk, and what should be distance between this to this disk? Have you ever think about that? In transmission line, this is not very much critical, but when we work in substation, this total overall length of insulator is sometimes very much critical. Sometimes the electrical clearances we are not able to meet out. So during that, this exact knowledge of distance between the disk, the this diameter we should know. And when we review the document, because we need to purchase this disk, so during the purchase of this disk, the disk manufacturer will provide you the diameter, the distance, the diameter between here to here, or we can say the length this of this disk, and between one disk to this disk, what is the spacing. This data they will provide. So how you will verify that given data is okay or not okay, right? So in that case, if we know the IEC 60305, that is it is not depend on the voltage rating. Voltage rating is the another things. Okay, I'll take Prasant. We'll discuss later on about keep these questions. So we will take this 60305 as you can see snapshot here, and figure 1, this D here, as you can see D here, and then P here, and this is the, I hope this snapshot is okay. 60305 I have taken snapshot, or should I need to zoom? And this is the model. B and P stand for the ball and socket type of the disk. Okay, and you can see here the D, this is the digit D, and these are the diameters, so 280 mm, and P is the spacing, that is 146 mm, and creepage distance, that is 440 mm, 440 mm, and this ball diameter is the 16 mm, or we can take 16 mm, or we can take 20 mm. This is the 16 or 20 mm that we take this ball diameter, this one. So if we know the IC standard, then we can review this disk drawing also, right? So that is why to know about the standards is also important as a design engineer. Now let me tell one again very important kind, very general kind of the electrical installations. I think when you go in industry, you see the transformer here, right? 1, 2, 3, and 4 trafo here. Between the trafo, we have this equipment, right? We have this one. What is this?
Buffer wall.
Bethel wall.
Firewall.
This is the firewall. So why firewall is required? When firewall is not required, and who is governing about the firewall? Which standard is governing that firewall? We have to provide. And when it is not required, and when required. Okay, so we have, because this is the firewall, so there is a standard that is related with the fire, that is called as the NFPA. That we call as the NFPA, National Fire Protection Authority. I think that is the correct name. NFPA. Please correct me if I am wrong. National Fire Protection Authority. So this NFPA recommend about this wall, that when we install two trafo that have the oil, between these two transformer, between two equipment that have the oil, we have to provide the fire barrier wall, and this fire barrier wall dimension, or we can say the length, width, and height shall be 600 mm, 600 mm more than this transformer largest oil height. I mean to say, I will take this transformer conservator tank where we have the oil, so this height should be more than 600 mm more than this oil. Why required? Because if the fire happens here, this fire should not go to this one, so that this trafo is safe, and only fire here between this one, it will not pass here. So when we aware about the NFPA, when we make the layout, we select the firewall, or where required, but not required. There is some cases that firewall is not required. It depends on the distance between two trafo. If distance is higher, in that case firewall is not required. Okay, so that is the advantage when we aware about the uh, standards, when we aware about the codes, and these codes we can apply into the designing. Let me tell one some few other example that why this is required. I have taken the snapshot of the surge arrestor and grid regulations requirement, and as per the CEA, as per the Central Electricity Authority, in the CEA they are telling that the surge arrestor must be fitted with the pressure relief device. This snapshot I have taken from the CEA. Let me open it. I think if I have the CEA, I think I have given the CEA to. I have the CEA. Yes, I have the CEA. The Electricity Authority, the Central Electricity Authority, Ministry of Power. And when we go to this regulations, and when we come to the substations, from where the page is starting of substation, yeah, from here. No, this is for the small. I think from page 66 they are starting the substations. I think you have gone through this, so please let me know from which they are starting the substation page. Where in this they are covering the power plant also actually. Have you gone through this these all document, or just you are putting, yeah, page number 25, chapter 4, technical standard for the construction of substation in the switchyard, part number A. Okay, and when we go to this regulations, in then we can found here, go to the surge arrestor mobile substations. Okay, then this send reactor controls, send reactor circuit breaker. So we need to follow this all for the circuit breakers and send reactors. This things to CT, VT, and surge arrestor. Yeah, and as you can see here, for the surge arrestor they have some specific requirement, that is by these regulations. Arrestor with composite insulator housing sufficient, maybe may setting. Okay, shall be, yes, yeah, these surge arrestor, so these shall be fitted with a pressure relief device and diverting ports suitable for preventing shattering of porcelain in housing, providing path for flow of rated current in the event of failure of surge arrestor. It means that when suppose when the surge arrestors fail during diverting the surge current to the ground, so if this fails, so there might be shattering of the housing of the porcelain housing. So to avoid that porcelain housing shattering, or to provide the flashover of this equipment must be provided the pressure relief device. So this requirement is coming from the grid regulations. So as a design engineer, we should also aware that what is requirement given in the grid regulations, so that during the design we can include that requirement, right? Okay, Lucas, I will say. So this, so that is why these all documents we need to go through uh, when we start designing of any subsystem, because these are the documents that provide us the knowledge, that provides us the correct that information, that how we need to proceed, or what kind of the facilities we have to take into the equipment, or when we are going to select the equipment, right? What happens, let me tell you one of my international project experience. I have put this comment to in one of my project. That project is executed by a company that is based in China, and that company rejected my comment, as I have put this there snapshot also. What happens that, just to show you, that I put here this surge arrestor. I ask pressure relief as capability. I have taken the IC reference, not this intent reference, not this intent reference, not this intent reference. But based on this reference, I put the comment. So what happens? This company, this is the Chinese language. This company replied me that such register has no such data. So to counter reply this contractor statement, I provided the reference that go to the IC 60099 part number 1, and I put here the refer clause number 5.1, class number 5.10, page 20 number 7, IC 60099 part number 1. That is also the standard for the surge arrestor. Surge arrestor must have the pressure relief capability, as it is short circuit current capability, means for relieving internal pressure in an arrestor and preventing violent shattering of the housing. So this comment I to means to counter reply their comment that they are asking, they are telling that such have no such data. We should have the knowledge of the standard so that we can counter reply. So I have taken the in place of the this Indian grid, I have taken the reference of the IC grid. So just I go to the IC 60099 and part number 1 and come to the 5.110 clause, and here this snapshot I replied to that in reply of their commit resolution sheet. So when you work as a design engineer, these kind of the things will also come, that the client will say that your vendor may say that there is no such data for that equipment. So if you aware with the standards, with the IC, with the IEEE standard, then you can counter reply, right? Yeah, Salis. Okay, I will share. Okay, so that is the reference, that why we should know these IC and IEEE standards. This is a snapshot of the bid clarifications. As I said that when we work for any government, then not only the tender specifications, we will also have to look out the bid clarifications documents. And in the bid clarification document, this snapshot, the client is provided for this transformer the no load loss and the full load loss value in that technical specification of the project, but they do not provide it the fan load loss, or we can say the auxiliary load loss. In the transformer we have three kind of the losses right now: no load loss, full load loss, and the auxiliary losses. Auxiliary losses come the fan losses, because we have the cooling fan, so when the fan rotate, they have the motor, so they will take the power, so that is a kind of the loss. So they have not given that losses. So during the bid, as a bidder or as a contractor, we ask to client to provide the auxiliary losses value also for the 500 ICT. In that case, the client replied auxiliary losses 15 kilowatt that we can take. So if any value is, so not only the tender specifications, along with the tenders, at the tendering stage, at the bidding stage, there is some bid clarification document also comes, so that documents also we need to go through, and this reply we can also include in the design engineering. Right now this is again some bid clarifications document. Here the scope of work is not correct, so that we ask to specify the correct scope of the work. So what we conclude here: so step number 1, scope of work; step number 2, technical specifications. And with respect to technical specifications, a lot of things we discuss, right? I hope step 1, step 2, both step is clear to everyone, and how to proceed with the IPP kind of the substance, that is clear to everyone. And we discuss that what is the importance of the IC and IEEE standards, why this standards knowledge we should also have when we work as a design engineer. But this fan is using to cool the transformer, that is why this fan loss is directly to the transformer. and the fan rating also provided by the manufacturer of the transformer. Okay, so three kind of the losses transformer have, as I said, no load, full load, and auxiliary losses, and the fan comes under the auxiliary losses. Okay. So I hope so far it is clear to everyone. So now we can conclude discussions so far what we discussed in the so far in this 1 hour. For the design engineering, we need to follow the project technical specifications, grid code, ISO and IETP standard, right, for the project. And along with the above document, here in class, we will also follow the ETAP software to simulate or calculate the statement or the concept whereas possible. I mean to say that I'm not going to tell you only the what is required by the what is given in the tender, what is required by the IC standards. Along with this IC standards, along with the IEEE standards, along with the grid regulations, that is CA, along with the tender specifications, in this session we will also take ETAP, so that I can, whatever statement I am delivering, that statement I can prove with help of the ETAP software. I hope this will make some more an additional interest in this session, right? For example, I said that uh, we need to connect the bus reactor. It is given in the technical requirement that we need to put the bus reactor. I replied, we have discussed that why bus reactor is required right now. Why the bus reactor is required, we have discussed. So we will simulate that concept with the ETAP also. So before uh, going to the simulations, let me give you the brief introduction of ETAP also, so that when in the session I'll take ETAP, you do not face any hesitations or any kind of the difficulty to use the ETAP. ETAP software we will take as the simulations, the calculations tool. So we need to open the ETAP. This is in at present I have the old version, that is ETAP 12.6, but in the class I will take the latest version, that is the 19 or 20. Okay, so we have one dedicated module for the ETAP also. Okay, so do not worry that I'm going to ETAP discuss now. We have dedicated session for the ETAP, so introduction, load flow analysis, capacitor bank sizing, reactor selections. These are is the short circuit current calculations, relay coordinations. So dedicated only in that we will discuss only for the ETAP. But during all this session, all these classes, we will take ETAP also to simulate the statement, to simulate the concept also, right? So since we are going to use throughout the syllabus, so that is why let me give some brief intro of this ETAP software. Yeah, so coming to the ETAP software introduction. First of all, we should know that which company is produce or make this ETAP software. What is the origin of this company? ETAP is a software name, that is not the company name. AutoCAD, who have what is the company of AutoCAD? Or the origin company of the AutoCAD? Yeah, that is Autodesk. Similarly, for the ETAP, we have one the version company that is called as the OTI. That is called as the Operation Technology Incorporations, OTI. So ETAP software developed by Operation Technology Incorporations, OTI. And due to this reason, when we save any file of ETAP, when we save any file of the AutoCAD, it save .dwg. Right now, when we save any file of the PDF, then it save .pdf or .excel, .word. So similarly, when we save any file of ETAP, it will save .oti file. .oti file, that will be the ETAP file. And why .oti file? Because OTI is the developer of this software. So this software is developed by the Operation Technology Incorporations, and due to that the ETAP file always save as .oti file. And full name of ETAP is the Electrical Transient Analysis Program, ETAP. Right. So coming back to the uh, to this. So when we are opening, so we will have this shortcut on the desktop. So just click on that shortcut. It will open like that, ETAP, and then go to the file and go to the new project. If every software file new project. So we need to start any project. We to start ETAP, go to the file, select the new project, and then this create new project. This kind of the pop-up window will open. I have already opened, so I can directly go file and then new project. Then here project file name, directly where I wanted to save, unit system English or metric, and we need to select the metric. And the American country, because few students from the USA also, they can go with the English based, because here we follow the metric system. The 50 years system, they follow the English, so they can go with the English system. At the 60 years based on frequency, if 60 years frequency country, then they can go, they need to go to English. 50 years, then we need to go to the metric in the system. So then click on OK, and we can create any new project into the ETAP, right? So I'm not going to create any projects. This is the example that how we can create. And after the project creations, this kind of the window will open. This is my ETAP, and here we have some tools, as we can see here, this here and this here. So what is meaning of these all to how it is appearing? So we have the menu bar. The menu bar contains the comprehensive list of menu options. Edit file, edit view. So this all, let me take this one, file, edit, view, project, library, rules. This is called as the menu bar of the ETAP. Let me take both. Let me this, and then yeah, ETAP, and then this one. So we have the menu bar. In the menu bar, file, edit, view, project, library. This all we can see. Thereafter, okay, we have to go like that only. Okay, so we have the menu bar. Thereafter, we have the project bar, toolbar. In the project toolbar contains buttons that provide shortcut for many commonly used functions. That is the use of the project bar. These functions are the create project. So here we need to go, and here we can see that is that new, open, save. So this is called as the project toolbar. So here we have the menu toolbar top, then here we have the project toolbar, right? Project toolbar. These functions: create project, open project, save project, print, preview, cut, copy, paste, pan, zoom, undo, redo, test box, grid display. So if we wanted to grid display here, so again we need to go to here, click this, and the grid will display here. So these facilities is given in the project toolbar in the ETAP, right? And thereafter we have some select ETAP system toolbar here. This one, as we can see here, these all things, and then to make any kind of the drawing, we have the equipment toolbar. So we need to go to ETAP here, and this here we have the equipment toolbar. So first of all, when we work in ETAP, we have to define that on which country we are working, or what is the code of the country. And across the world, there is two standard that we follow globally. One is the IC, and second is the IEEE standard. IC standard is basically the European standards. That is, the European country follow the IC standard. So European, and the country that is influenced by the Europe, they country like the Asia, like India, the Sri Lanka, Saudi, Dubai, these countries, this Bangladesh, these country, all country follow the IC kind of IC standards. But the USA, the country near about the USA, like Canada, USA, North America, these countries follow the IEEE standard. This is the American standards. So we have to define that will be my standard of the project in the in the ETAP also. So for that we can go to here project and we can select standards, and there is we can select here. As you can see, there's two global standards. So in IC again we have two options, IC and ANC. ANC means the IEEE, means American National Standard Institute, ANC. So based on that, equipment symbol will also change. Suppose you can see this kind of the equipment symbol, this kind of equipment symbol. Let me switch off this grid, and let me take any trafo. Yeah, as you can see, this is the trafo. So this is the IC base symbol. Suppose I wanted to use the ANC base symbol. So there's a two options. We can go here and we can change the symbol as the ANC. This one, now you can see this symbol is now changed this kind of. So this kind of the representational transformer is comes as the ANC standards. Or second, another way, that initially in the starting of the ETAP project we can go to the project standards and we can define the global standard ANC here. So all the equipment symbol will automatically change here. So if we drag here and it will draw, so no need to change the equipment symbol one by one, all the equipment symbol is changed. So equipment symbol is given, and the equipment symbol type or representations we have to take that on which country we are working. That country follow the IC IEEE standard. Based on that we have to select in ETAP the project standards. Generally we take IC, so we will take IC and then we click OK. Right. So this equipment toolbar is also given, and when we make any kind of the drawings, so we have to drag. So what kind of equipment toolbar we have? So this is my AC equipment. These are my AC equipment. This is all my meters and the relay. As we can see here, as you can see, electrical bus, transformer, open delta. This is the cable, reactor, current limiting reactor, not the shunt reactor, the power grid. So when I work, that I'm taking supply from the electricity board. So electricity board in ETAP software we will indicate by this symbol. As you can see here, this symbol stands for that electricity board. It means I'm taking supply, income or supply by the grid, by the electricity board. So I will use this symbol in the ETAP. If you click this symbol editor block will open, and we have to put the data in this block, in this grid editor block. Okay, so rated voltage, that how much voltage we are taking. So the rated voltage, and then fault rating and short circuit rate X by R. So these are we will calculate in the ETAP module, but in the class we will go as per the conventional and industrial practice. So this data we will fill, but when it comes to ETAP, then all these things X by R, this all I will calculate and show you that how this is 14 or 17, what value we have to take. So this will come from the calculations. Okay, so this AC symbol here we have, then we have all the instrument here, then we have this DC instrument also here. So what kind of the equipment we have? So AC element toolbar we have, then we have DC element toolbar. This is the DC element toolbar, and then here we have instrument toolbar. So when we are going to make any drawing, what I will do, I will just drag the equipment from here. I mean to say, just click here and then put here. So this equipment drag and drop only we have to perform. Just drag and drop the equipment. So based on the network, we will drag and drop the equipment here. And suppose any equipment we wanted to delete, then please use shift plus delete. Do not the delete only, because it will go and save in the recycle bin. as a system dumpster. In ETAP software, the recycling bin called as the dumpster. As you can see here, it is coming dumpster, right? And to perform the calculations, here we have the analysis mode bar here, as you can see here. This one, this one, this one, analysis mode toolbar. So this is my edit mode. So when this pencil is down like this, then we are in the edit mode. If this pencil is this position, then we are in the running mode, means we are in the analysis mode. So for edit, please keep this pencil down here, then edit. And this is my analysis mode. So with help of this P and Q, we can do the load flow analysis. This P and Q, we can do the load flow analysis, because we know the load is active and reactive load. The active load by the P, reactive load by the Q. So this is coming P plus Q, right? So we can do the load flow analysis with these options. With these options, we can do the short circuit analysis. Click here, and then they are asking that what kind of the method we are going to use. This IC already given here. This is the options that we will take as per the requirement. And then motor and acceleration study, then we have the harmonic study, then we have the transient study, then we have this relay coordination. So when the ETAP will come, then this analysis mode we will discuss, but during the class we will take this load flow and the short circuit analysis. Both frequently we will use in the class. So just make the SLT, make the drawing, and then just put on this symbols. So as I said in my previous session, that we use the line reactor in order to compensate the reactive power that is injected by the capacitance. Right now, that was the reason. So we can take any grid, right? So we just make one substation. So here we have one substation. This is sending in substations. So we have grid, electricity board grid here, and then we have one bus bar. This bus bar, just then connect here. This is my one substation, right? Board and then bus bar, this one. And then let me take the transmission line. This is my transmission line symbol. Just drag and drop here. And then we have one receiving in substation that is placed here. This is the receiving into substation bus bar, and this line base connecting. This line base coming from this sending in substations. I hope this is clear to everyone, right? And let me just, and to provide the values, we have to just double click on this here, and then we need to value. Suppose this is my 400 kilovoltage substations, right? 400 kilovoltage substation. So I put the voltage and then nominal kV, and then click on the OK. And again, this will be the 400 kilovoltage because we are taking 400 kilovoltage. So this is 400 kilovoltage, and click on the OK, right? And here rating again 400 kilovoltage after sending in substations. Or you can see the grid, the source 400 kilovoltage. So I'm putting the voltage at 400 kilovoltage. Another, no need to put here, only voltage we need to put here. This is my interconnecting transmission line right now. So I'll just click here, and let me put the length of transmission line length, right? So let me put any longer transmission line. So we can go to the 300 kilometer, 350 kilometer, like that, unit into kilometer. And then let us take any transmission line conductor parameters. So I will just select any random, any kind of this transmission line parameters that we can select any value. Click OK, right? And then this is the configuration of the transmission line. So the line of height of transmission tower is suppose 24 meter above from the ground, this height, so 24. R ABC means R by B phase, so I'm putting the spacing, suppose 6 between R and Y phase, so 6 and 6, like that. Then okay, impedance value, this is automatically taken based on the parameter that we have entered. The line, the positive, negative, and zero sequence resistance, reactance, susceptance. Then click on the OK. And that is the beauty of ETAP, that they will take the parameters by default when you define the type of the conductors. Now let us go to the, as I said that reactor is required. Let me ask, I think everyone is clear that why reactor is required right now. Why we require the bus reactor? To compensate the reactive power. Am I correct? And that reactive power who is feeding that reactive power is injected by the line shunt capacitance. Let me go to again the this class earlier session, and here we have taken this project, and here in this project the client asked to the shunt reactor, to the bus reactor, right? So I asked that why this reactor is required. So we discussed that what is the shunt reactor. Shunt reactors are used in order to compensate the reactive power generated by the shunt capacitance of transmission line. And then we have seen that what is the model of any transmission line. So any transmission line have the inductance, resistance, and the shunt capacitance. This is C. So this C is feeding the shunt reactive power to this line. And when this line is the longer transmission line, then C is value is more. And suppose this line is not loaded or lightly loaded, and it is feeding the reactive power, then voltage is going to increase at the receiving end substation, and that effect we refer as the Ferranti effect, and that also we study in the college time, that what is the Ferranti effect. So I'm going to simulate about the Ferranti effect, right? So I have taken this transmission line, this length 300 kilometer as that I put here, and now because it is linked with the reactive power, so we have to do the load flow analysis, and we have to see the active and reactive power. So let me put here P and Q. So when I click here, then you can see here that it is coming again this option. So I need to put run load flow. So I put on the run load flow here. Run load flow here. So I just click run load flow. Yeah, what you observe in the run load flow? Can anyone tell me the observations here? What is their observations here? Let me show you the unit. Yeah, unit already here. Okay.
Receiving and send voltage increases.
So my sending in voltage is 400 kilovoltage. Yes, that is fine because we have put the 400 kilovoltage here. We put the 400 kilovoltage my bus voltage. But what I see that at the receiving bus number 42, and that is on the red color, rated voltage is 400 kilovoltage, or the voltage is 400 kilovoltage, but this is coming for 20.2. So 20.2 kilovoltage additional it is come, and this concept we call as the Ferranti effect, that at the receiving end voltage is higher than the sending end voltage. So this statement we read into the college time, and now this statement we can validate here with help of the simulation software. So that is the beauty of ETAP, that we will take ETAP throughout the sessions to simulate the concept, to simulate the engineering concept or the statement. Okay, so we are simulating one statement, one concept, that is the Ferranti effect. So yes, we can see 400 kilovoltage and 420 kilovoltage. So we should know also that how this 420.2 volt kilovoltage who injected. So that is injected by the line shunt capacitance that injected the reactive powers. And what about this 168? What is the meaning of this 168 here? This is clear, right? What is this? 168 is what?
Sir, load.
How much? What is?
Load, sir.
There is no any load R on the bus. You see, bus 42 unloaded. Now there is no load connected on the bus. I will connect the load, no issue. I will go on the load, but without putting any load.
Is it the charging current?
Correct. That is the charging current. So where it is flowing? This is 168 amp is the line charging current. Where it is flowing? Where it is flowing to the capacitance of the line, shunt capacitance. So this 168 ampere it is flowing to here. This much. 168 ampere flowing at the charging current. There is a lot of concept that we can discuss on that. This is called the line. So this is called as the line charging current. This is the correct name for this. This is flowing to the capacitance. When we are doing any relay settings, the relay setting value, the relay setting current value should be more than 168 ampere. Otherwise, every time your relay will operate, every time your relay will pick up, every time your relay will use the drip command. But that is not the case. It faulty case. So this is the line charging current. Your settings should always more than 168 ampere. That is one criteria that we follow when we do the relay setting calculations also. Okay, now let me put some load. So now okay, so we have done the simulation. So how to mitigate this Ferranti effect, how to mitigate this over voltage issue, and how to mitigate the this shunt this reactive power. So we have seen that to mitigate this shunt uh, reactive power injected by the capacitance, we need to put the bus shunt reactor, or we need to put the line shunt reactor. So in ETAP we do not have any shunt reactor, but for that we take the static load, and this load, by this load we take as the shunt reactor. We do not have any symbol for the shunt reactor. So static load work as a shunt reactor when in ETAP for the simulations purpose. Okay, so now let me see how much power is flowing. And if we wanted to see any other unit, okay, they are telling that this load is not defined. Let me take out of service this load now. And when we wanted to show that how much active and reactive power is flowing through this circuit, so for that we can go to the display options here in the ETAP, and then see here that what kind of the display result we want. At present I click on the ampere, so that is why it is showing the 168 ampere, right? If I wanted to show the active and reactive power how much flowing, so I need to put here kW plus j k var. So I click here kW plus j k var. Now this ETAP will indicate the flowing active power that is in the kilowatt and the reactive power that is in the k var. Click on the OK. Now we can see here, and let me see this value in not in the kVA. Let me take this value in the MVA. So yes, now we can see here 5.8 kilowatt plus J116.2, this much kVAR. And did you notice the symbol minus J? What is the meaning of minus?
Leading set.
Leading
Minus
capacity.
means we are not taking from the grid, we are injecting to the grid. Means we are doing the reverse supply. Means we are feeding to the grid, we are injecting to the grid. So during the ETAP study, if any symbol comes with the minus, please make a note, it means the reverse power is flowing. Because what is required, we have the source here, we have the load here. So this the power, required power should be come from the source, but what happens here that this much power is reverse feeding to the source by this system. So when this kind of system comes, means when there is a reverse power flow, when there is a uh, power we inject to the grid, or we feed power to the grid, then the symbol will come with the minus. So please also keep this point in your notice when we do the ETA. This will help us. It means with help of the shunt capacitance, we are injecting the 116.2 mVAR power to the grid. So if I put the 116.2 mVAR rating here, the this shunt reactor rating, then we can, this reactive power, in place of feeding to the grid, we can consume with help of this reactor. So this reactor rating we can take based on this power. So let me go to this static load, and then service in, then go to the loading. And what we do, actually there is one more concept we do, that in place of putting all the 116 mVAR this reactor uh, to the ones to only one substance, we can split in two part. Means I am going to put some reactor here and some reactor here, because this, when this is feeding to the power, we can refer to this transmission line model. When we are feeding to the reactive power, here we have sending in bus, and here we have receiving in bus, so it is going both directions. So we can bifurcate 50-50, and we can put like that also. This is also one option that we can go. Anyway, so I'm just taking in some value randomly, and we will see that how much impact on the reactive power. I have not used, I was taken out of service, now I'm going to use. Okay, so now let me put service in loading, and I'm just putting some rating, general rating, 60 MVAR, 90 MVAR, 120 MVAR. That is the rating that we take generally. So I'm just putting 60 MVAR, 60 loading. This 60 MVAR or 60 megawatt as that also we can take. Yeah, 60 MVAR I'm just taking. Now click OK, and then again let us do the load flow analysis. Yeah. Now what is the impact when we put the 60 MVAR rating here? Yeah, I again show you 61 MVAR rating we put here. What is the impact? What we observe here, that voltage suddenly fall down from 420 kilovoltage to 398.8, means it is 399. It means it is near about 400 kilovoltage right now. So when I putting this reactor, so that is why if you see here, that is why if you go now, let me take now your project here. So every extra ultra high voltage substation that having the 400 kilovoltage and 65 kilovoltage, these kind of the substations frequently use the bus reactor, or they frequently use the line reactors. Why they use the bus or line reactor? To mitigate the Ferranti effect, to mitigate the to the to compensate the reactive power that is injected or fitted by the line shunt capacitance. I hope this statement is clear. Even though I'm just telling you that this is the requirement asked by the client, but I'm going one or two step above to this requirement. That why reactor? We discussed that yes, reactor why required to mitigate Ferranti effect, and with help of ETAP we simulated and we see the result also right now. So this ETAP also we will take throughout the sessions to simulate the concepts, right? So what we discussed so far, let me conclude step 1, scope of work, step 2, these all things we discussed, and we have seen that along with this technical specifications, the CEA, IC, IEEE standard, and then in this class locally, just for our understanding, do not use the ETAP for the project, because for the project you need to follow the project requirement only, and for the ETAP we do another kind of the project. But here in the class, and for the ETAP we have another kind of the deliverables. In that deliverables we will do the ETAP analysis. Okay, in this entire class we will take the ETAP as the reference, as a reference software, to completely and crystal clear understanding of the concept. Okay, so now yeah, I think we have gone some idea. Okay, so next, step number 3. What is step number 3? That step number 3 is that okay, let me come. What is step number 3? Yeah, now we need to read out the technical specification. So what I'm doing, let us have some session and let us understand that how to read the technical specifications for any government kind of the service or for any kind of the service stations. So what is the important parameter that we have to read out, that we have to make in notes. Okay, and before going to the technical specifications requirement study, we'll discuss that what is the overall total process that we do for any kind of the project, starting from the bidding and up to the energizations, right? So what I think that is it is going to take the long time, so we'll keep this session in the next class. Okay, so that tomorrow we'll discuss about the overall process of the project, and after that we will enter into the technical specification study. in that, what I'm going to do, that I'm just taking the requirement given in the tender. I'm taking the requirement that given in the tender here, as you can see here, and I'm just doing analysis that why this requirement coming, what is the use of that requirement, why client ask this requirement in the tender, what is the understanding of that requirement, how this value coming in that tender. So these all further analysis we will do, the now analysis of the project, analysis of the requirement. Again we will take the IC, IEEE, ETAP, these all against to understand the technical requirement given in the project. So this we will keep in next class. So tomorrow we have the class, so in that we will discuss the total overall engineering process of the project, and then we will move to the design engineering process. We have some design engineering process, and then we will study the how to read any technical specifications or requirement of study. So we will take the tender, we will take the project snapshot, and we will do that analysis with help of IC and general understanding. These all things we will keep. I hope so far it is clear to everyone. Yeah, correct. No? Calculations we will, when we will come on that, then we will give. Yeah, because they might have two or three transmission line, and both transmission line is a longer transmission line. So in place of putting two number of line theater, they're putting one number of bus reactor. So you are able to reduce the quantity of one reactor, right, Mehul? Okay, so we are now closing the session, right? This, and we can move into the query Q&A session. Okay, or we can keep the Q&A session by tomorrow. Suggest me your comfort table, and your drawing I will review by tomorrow or day after tomorrow. This weekend I will review, and others please also come.
सर ड्राइंग सर एक बार इसे भी
Yeah,
तो
we will review.
वो जो ड्राइंग वगैरह था वो एक बार बोल